So hello guys, today we have another problem that is k closest elements, and the question states that you are given an array and a target value that is x. You have to find all the closest elements of the value of kx. If x is present in this array, then we cannot consider x, and we have to calculate all the nearest values, that is 4 here, and if the x is not present in here, then we have to calculate for the other k number of closest values that they are given in the array. Suppose we are taking this example, and if you carefully see that uh, 35 is here, and the closest element, what can be there? Basically, the closest elements are 39 and 30, then 42 and 45. How can I calculate the closest element? Basically, we have to check for closest elements, that is initially 30 and 39. Then we have to calculate the absolute difference. So 35 and 39, what is the absolute difference? That is 4. And here that is 5. So which one I have to consider? Obviously 39. And then I can consider 30. And then the only way, that is 42 and 22. We have to calculate the absolute value again. And what is the absolute value of 35 and 42? That is uh, 5 and 7. And here you can see that 8 plus 5, that is 13. So we can clearly select this 42. And there is another condition, that is, if suppose there is, I'm taking another example, that is 1, 2, 5, and suppose the value of the k, that is 1, and the x, that is let us take 4 and change it into a 3. Okay, so we can clearly see that 4 is not present in here. So what can be the closest value? That is 3 and 5. And obviously, if we put 4 here and make the calculation for absolute values, that will be 1, and here that will be 1 also. So which one we should take? The greater one. So the answer will be 5. And also there is another condition. Suppose the value of x, that is 14, and the k, that is 2. So obviously 14 will lie here, and there is no element at the right hand side. So we have to consider both two left hand side elements. The answer will be 5, then 3. Okay. So this is the question, and obviously the array that will be sorted, and the time complexity that they are asking for, that is log n plus k. So extra space, that is k y. We have to return k number of elements into a vector. So we have to use k. And one thing is sure, that they are asking the solution to have log n time complexity. How can I get log n time complexity? Obviously, we can use binary search here to find the element, if the element is present or not. So what can we do? So the first step will be to calculate the element, the position of the element, if it is present or not. And secondly, we have to calculate the nearest elements. So the problem will be divided into two sections. One will be binary search, another will be finding the closest elements. So let us start from the binary search. So I am considering this example. Okay. So let us make it into a single line. How can I do it? Great. So now we have this example, and if we calculate for the binary search, and what is the value of k, that is 35. Sorry, x, that is 35 here. X is 35. Okay, great. So we will apply binary search here. So starting will be L, it will be R, what will be the middle? Let us suppose this is the middle. I'm not calculating in the perfect way, and we can discard this part because x is lesser than mid. So mid will be this one, or you can say this one. It all depends on the algorithm. So what will be the value of x? That is 35, that is greater than 30. So remove this part, and now this is the L, this is right. So what will be the middle? It will be the middle. So middle is matching to the 35. So we are getting the 35. So obviously I have told you that we cannot allow 35 here. We have to calculate for the other elements because k is 4. So we have to calculate for the other elements, that is what will be the closest one, that is 39, then 30, then 42, then 45. This will be our answer, right? So binary search part will be clear, and obviously there is another condition, that is if suppose this is 36, so 36 is not present here. So if we run binary search, then we can clearly get that the position of the middle, it will point either at this position or this position. Suppose our target is 36, so our middle will either point to this position and either point to this position after while loop. Okay, so then we have to check for the target if it is greater or not. Why we are checking for that condition? Let us discuss how to get all the adjacent elements, and then you can have a clear idea why I'm talking about it. So basically, now let us try to calculate all the closest elements. So how can I do that? Suppose we have 36, 35. We have reached 35. So what is the position of the 38? That is 0, 1, 2, 3, 4. Okay. So one thing is sure that we cannot take this value. So we have to calculate for the previous one and the next one. How can I do that? Obviously, for previous one, if let us say this is L, so it will be 4 minus 1, that is 3, and right, that will be 5. 4 plus 1. We can easily calculate the next and the previous element. And why I am calculating for these positions? Let us discuss that at first. So what can I do? Basically, we have now 30 and 39. Let us take another two variables, that is A and B, which will help us to store the absolute values of two adjacent elements. For this one, what is the absolute value? That is 5, and we are storing 5 here. And for this one, we, how, what is the absolute value? That is 4. So which one I have to choose? Obviously, lesser one. For this reason, we are calculating for the previous and next value, and the absolute values that we are needing for. Basically, we now we can determine which one I have to choose. So obviously 4 is lesser than 5, so I have to choose 39. Now this pointer, I have to increase this pointer. Why? Because I have already included in my answer, so I have to increment it by 1. So it will be 6. So the pointer, that is, okay, let us clear these pointers. Sorry. Okay. So let us remove also. Hmm. So currently our R pointer, that is pointing to this element, and the value of X, obviously this one, 55, and the left position, that is pointing to this one. Okay. And now we have to modify this value also. Now absolute value, that is 42 minus 35, that is 7. Now which one is smaller? You can clearly see that 5 is smaller, so I can include 30 into our answer. Now L will be decremented by 1, that will be 2. So L will point here. Great. So let us calculate or update this value also. What will be? That is 35 minus 22. That will be 13, I guess. Okay. So which one is smaller now? That is 7. And so we have to take 42 here. R pointer will increase by 1. That will be 7 now. Let us move R and calculate the B value again. That will be 45 minus 35, that is 10. Now which one is smaller? Obviously 10 is smaller. So we can take 45 here and move the value of R here. And you can clearly see that the number of K, that is 4. We are already considering 4 elements. So we have to stop the while loop and go outside and return this answer. So this is how we can calculate for the closest elements or nearby elements. So basically our problem is divided into two parts. That is, one is the binary search, and the second one is to find the closest elements. So this is the approach that we are considering, and obviously there is an edge case. Suppose the target is uh, 70. Obviously 70 is not present in here. So our mid pointer will point to this element, and we will call for the adjacent nodes, and you can clearly see that if I pass the mid plus 1, then it will be out of bounds. So we have to think about it, and in our coding part, we will basically put int max or something like that to avoid this kind of conditions. So let us move back to our code. So first of all, we have to apply binary search here, and it is straightforward. Int L will be 0, int R will be n minus 1, while L is equal to R. We have to continue int meet. Okay, so I'm taking meet here for a reason. Let us discuss later. Uh, let us say it is minus 1, and meet will be L plus R by 2. And if our target, that is, what is the name of, okay, yes, if it is X, and the array of meet will be equal to this one, so we have to simply call the function. Let us write the function later and return the value. So if X is greater than error of meet, so the target is greater than the error meet, means we have to reduce the left part. So basically left will be meet plus 1, else right will be meet minus 1. So this is our basic binary search, and then we have to check for two conditions. That is basically uh, suppose 1, 2, 5, 7, 9, and the value of X is 3. Obviously 3 is not present in here, so after value the mid will be either pointing to this one or this one. So if uh, mid is pointing to this one, we need to calculate for the next element. Suppose mid is pointing to this one, so we have to pass for that function. We have to pass two elements, that is current mid position and mid plus 1, this to 1. And if mid is pointing to this one, so we have to pass mid and min minus 1. Basically, if X is greater than mid means x is pointing, suppose x is pointing here and mid is lesser than x. So you have to send mid and mid plus 1. So in this case, we have to send mid and mid plus 1. And here, if x is lesser, then we have to pass mid and mid minus 1. So this is the two conditions that we have to follow. Basically, we can copy paste from here. Uh, where is the code? Where is the code? Okay. So if x is greater than error of mid, we can simply call for that function. Let us name it fluency. And what will be the two positions? That is, one is mid, another one is mid plus 1. Obviously, the array, the value of k and x. Else, we have to return func mid minus 1, or you can say it will be better for us. Mid minus 1 mid error k x. Great. So this function will return our answer. And if we have reached to the position of the particular element, then we cannot allow that element to be included into our answer. So here return func mid minus 1 mid plus 1, sorry, and error k obviously and x. So let us try to write the function that will return vector int func, and what is the parameters? That is int left position. Let us name it left. Int right position. Int vector. Sorry. Int array and value of k int x. So this will be our function, and let us try to write all the thought process that we have talked about. So int l, it will store the leftmost absolute value, the initial leftmost absolute value, that will be abs of error lf minus x, and int r will be abs of error rt minus x, sorry, x. So this L and R will store the absolute values of the left hand side and right hand side. Basically, what I have told you, initially the position will be this, and the left value was initially here and the right value was initially here, and we had to calculate the absolute values that we needed for. So that's why I have calculated this absolute values here. So now let us take the vector that will be our answer. Okay. So while k minus minus until the value of the k is 0, we will continue. And I have talked for that base case, we have to keep in mind because the index will be out of bounds. So if lf, sorry, what is okay, lf, and if it is less than 0, so we have to take L as int max, and for RT it will be, if it will be greater than error dot size, then we have to take R as int max. Why int max? Because we are getting the minimum value. So if there is int max, then we cannot consider that one basically. So let us go to the main condition, that is if L less than R, basically the left adjacent, sorry, left absolute value. If the left absolute value is lesser, then we will consider the left one. Otherwise, we will consider the right one. So that we are going to implement here. So ans dot push back, that will be error of LF and decrement it by 1. Why decrement it? Because we are considering this value, so we can decrement the value of the L. So now I have to update this value also A and B. Let us, obviously the name was different here. Basically, this is A and B. Here I am writing L and R. So we have to update the value of L. That will be ABS of error of LF and X. Otherwise, we have to consider the rightmost elements. So dot push back error of RT, that will be plus plus, because we are considering that value, and R will be updated. So ABS of error RT minus X. And lastly, we can return the value of the answer. So let us recap again. Here, what I am trying to do, basically, I am trying to calculate the absolute value of both two sides, and I am making the answer vector. And if this absolute value is less, then we can consider the left element. Otherwise, we can consider the right element. And when we are considering one element, so we have to move forward. And so that's why I'm doing minus minus here, and here I'm incrementing by 1. So, and then we have to also update the current absolute value of both two sides, and this is how we can get all the closest elements for a particular position. And obviously, this is the basic binary search, and hopefully everything is right. So let us try to run our code. Okay, so this is working fine. Let us take another example, and obviously we will check for this example also, because this is a good example. And yeah, so this is working fine, and let us try to submit our code. Okay, so it is working fine. So this is how we can make an approach by using binary search. Obviously, the time complexity that this algorithm is taking for while loop, it is obviously log n, because it is basic binary search, and we are calling this function for particular situation. Obviously, there is three situation. One of them will be occur, and this situation are mutually exclusive, so they cannot occur both at the same time. So here n log n is a log n, and here is the value of k. So k plus log n, that will be the time complexity, and the space complexity, that is k, obviously, because we are taking extra space to store our answer, and this is how we can solve this question and satisfy all the time complexities. And basically, when I am solving this problem in the morning, so they have actually put this array unsorted. So there are some arrays, those are unsorted actually. So a lot of things happened then, and after all, the problem is uh, reconstruct again, and now they have given the sorted array. Initially, it was not a sorted array. Okay, so this is how we can solve this question. And if you understand whole concept, then subscribe, and thank you. See you in the next video.